All right, so it's spring break. Thought we would do something a little bit different. Some of you have had this lesson before, but this is one that you can have your parents do. You could probably have younger brothers and sisters do. This is multiplication from other cultures. And the coolest part of this is you don't need to know any multiplication facts. Now, the first thing we're going to talk about is Egyptian multiplication. The Egyptians are known through history as being amazing mathematicians. Not sure that this method is really taught much more right now, but this is great. You can do this. All you need to know is addition. So let's take a problem like 27 times 38. To do Egyptian multiplication, we're going to make two columns. Under the 27, we're going to start with a 1. And under the 38, we're going to start with a 38. Now, 1 plus 1 is 2. And 38 plus 38 is 76. 2 plus 2 is 4. 76 plus 76 is 152. 4 plus 4 is 8, and we'll double 152, excuse me, we'll get 304. 8 plus 8 is 16, and 304 plus 304 is 608. Now, 16 plus 16 is 32. 32 is bigger than 27. We don't have to go any further. Now, what the Egyptians did once they wrote this out was, without reusing any numbers, there is one unique combination of these numbers in the left column that will add up to 27. In this case, those numbers are 16 plus 8 plus 2 plus 1. 16 plus 8 is 24, plus 2 is 26, plus 1 is 27. We're going to take the numbers that are across from those. 608, 304, 76, and 38, and we're going to add them. 8 plus 4 is 12, plus 6 is 18, plus 8 is 26. 2 zeros makes 2, plus 7 plus 3 is 12, carry the 1. We get 1026, and that means that 27 times 38 is 1026. Now I'm going to put a problem up. What I want you to do is pause the video and solve it yourself using the Egyptian method. Then we'll come back and solve it together. So I'm just picking two numbers here. We'll do 39 times 63. I want you to pause the video and try it using the Egyptian method. Okay, we are back. Hopefully you solved it, but let's do it together now. We're going to start with a 1 always in the left column, and the right column will be whatever the other factor is. It's much easier usually to start with the smaller number on the left. 1 plus 1 is 2. 63 plus 63 is 126. 2 plus 2 is 4. We'll double 126 by adding it, and we get 252. 4 plus 4 is 8. 252 plus 252 is 504. 8 plus 8 is 16. Well, 504 plus 504 is 1008. 16 plus 16 is 32. We get 2016. And 32 plus 32 is bigger than 39. We don't have to go that far. To get to 39, we've got 32 plus 4 plus 2 plus 1. That means we're going to take the numbers that are next to it. 2016, 252, 126, 63. 6 and 2 is 8, plus 6 is 14, plus 3 is 17. 1 plus 1 is 2, plus 5 is 7, plus 2 is 9, plus 6 is 15. 1 plus 2 plus 1 is 4, and we bring down the 2. 39 times 63 is 2,457. You can go on a calculator and check this. By the way, with these problems, you don't need me to write problems. You can try any problem yourself because you can find the answers yourself. That is Egyptian multiplication. Now, the next one has several different names. Egypt, by the way, is in the Middle East. It's also in the northeast corner of Africa. The second one is often called Ethiopian multiplication. Ethiopia is a country in Eastern Africa, but it also has several other names. It's called Russian multiplication. And sometimes, because it's called Russian multiplication and it was taught to the poorer people in Russia, it's called peasant multiplication. And my understanding is that this is still taught in some places in the world, not many, but it has several different names. And it looks sort of similar to Egyptian multiplication, but with a twist. So we're going to take a problem. We'll take 32 times 57. And in Egyptian, we started with 1, but here we're actually going to start with 32 and 57. One other name for this is called halve and double, and we're going to see why in just a second. Half of 32 is 16. We're going to double 57. We're going to get 114. Half of 16 is 8. We're going to double 114. 114 plus 114, we get 228. Half of 8 is 4. And we're going to double this. We're going to get 456. Half of 4 is 2. 456 plus 456 is 912. And half of 2 is 1. And the answer we're going to get is 1824. Now, in this case, this is actually going to be the product. And the reason, and I probably should have thought through what I picked as our first problem, is anything that has an even number over here, we're going to skip. The only ones we're going to choose are the numbers across from the odd. So before you pause, let me give you another problem that has a lot more to the example than maybe this one did. Let's do 45 times 61. Half of 45 is 22 and a half. Well, 22 and a half we can't use. The Egyptians just ruled out the halves and took 22. We're going to double 61. 61 plus 61 is 122. Half of 22 is 11. 122 plus 122 is 244. Excuse me, half of 11 is 5.5. We're going to eliminate the 5. 244 plus 244 is 488. Half of 5, excuse me, is 2.5, but we're only going to use the 2. 488 plus 48 is 976. Half of 2 is 1. 976 plus 976 is 1952. Now we're going to take all of the odd numbers over here, 45, 11, 5, and 1, and take the numbers next to them. So we're going to add 1952, 488, 244, and 61. We get 2 plus 8 is 10, plus 4 is 1, plus 1 is 15. 1 plus 5 is 6. Our dog is needing attention here. Plus 8 is 14. Plus 4 is 18. Plus 6 is 24. And 2 plus 11 is 2 plus 9 is 11. Plus 4 is 15. Plus 2 is 17. Carry the 1. And we get 2,745. Now, what I want you to do is, I'm going to write down a problem. You will pause and solve. Let's try 63 times 77. Pause it. Try it using the Ethiopian or Russian way, and come back in a second. That's Bibi. And here we go. Bibi hasn't been in any of our videos before. Half of 63 is 31.5. We're only going to take the 31. Double the 77, we get 154. Half of 31 is 15.5. We're just going to take the 15. 154 plus 154 is 308. Half of 15 is 7.5. We're going to double, take this, just the 7. 308 plus 308 will be 616. Half of 7 is 3.5. We're just going to take the 3. 616 plus 616 is 1232. Half of 3 is 1.5. We're going to take the 1. 1232 plus 1232 is 2,464. Now, all of the numbers on the left are odd numbers. We're going to add every one of these together. And 4 plus 2 is 6, plus 6 is 12, plus 8 is 20, plus 4 is 24, plus 7 is 31. Carry the 3. 3 plus 6 is 9, plus 3 is 12, plus 1 is 13, plus 5 is 18, plus 7 is 25. Carry the 2. 2 plus 4 is 6, plus 2 is 8, plus 6 is 14, plus 3 is 17, plus 1 is 18. 1 plus 2 plus 1, we get 4,851. And again, you can try these problems with any numbers. Just check on a calculator. Our last method, you need a little bit of background for. This is the only one place where you might need some background facts. Now, sometimes at Colfax, we used to teach what's called lattice. Lattice works like this. Let's suppose we're multiplying 25 times 34. Well, lattice is sort of an idea about partial products. We're going to write a 2 of 7 there, and we'll write 34 here. And we're going to make diagonal lines that go here. And for each one of these, we're actually going to do, you need multiplication facts just for this part. 2 times 3 is 6, so we'll put 0,6 there. 7 times 3 is 21. We'll write it like that. The tens digit goes above. 7 times 4 is 28, and 2 times 4 is 8. What we're going to do is we're going to follow the diagonals. So here we've got an 8. We're just going to add the diagonals. There's only one number in the box there. In the tens place, we've got 1 plus 2 plus 8. That's 11. So we'll carry a 1. 1 plus 2 plus 6 is 9. And there's nothing here. So 27 times 34 is 918. Now you don't need to know lattice, you don't need to know multiplication facts to do our last kind of multiplication. But I wanted you to understand the part about the diagonals because it's important in Japanese multiplication. Japanese multiplication is probably the one that you can teach people that are younger than any of the others. Let's say we're going to multiply 14 times 23. We're not even going to write out numbers here. In Japanese multiplication, we're going to represent 14 with one line and then 4 lines. And we have to separate them. 23 we're going to make in the opposite direction with 2 lines and then 3 lines. Now, just like in lattice where we add the diagonals, we're going to do the same thing here, but what we're going to count is the number of intersections of lines. This is the ones place. This is the tens place. And in this case, this is the hundreds place. In the ones place, there are 12 intersections of lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to put a 2 here. We'll carry a 1. In the tens place, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, plus the 1 makes 12. We'll put a 2 there and carry the 1. In the hundreds place, there's 2 plus 1 is 3. 14 times 23 is 322. Now, that's all you have to do. It's much easier if the digits are small. So for this one, I want you to pause it, and I want you to do 32 times 41. Okay, hopefully you did this. Let's try it together. 32 will look like 3 lines and 2 lines. 41 will be 4 lines and 1 line. This is our ones place. It's a 2. This is our tens place. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we'll put a 1 here, and we'll carry the 1. And this is our hundreds place. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Plus 1 is 13. We get 1,312. That is Japanese multiplication. This is something that you don't need multiplication facts for at all. When we have lots of time in class and I teach this, sometimes they make kids try to do 1, 2, 3, 4, 5 times 5, 4, 3, 2, 1. You need a whole sheet of paper. You need to keep your lines separate and neat, but it's a lot of fun. Everybody be well, be safe, enjoy your spring break. Next week we'll actually be doing some more one-to-one learning online. So have a great break, be safe, healthy, and thanks again to my wife for recording. Thanks to BB for making her first appearance in a video, and to Rocco for not barking from wherever he's at today. Take care. Bye.